Hi guys, today I'm going to talk about how you calculate the areas of some of the shapes that are common. Now, often tutors and teachers show you how to do the calculation, but they don't show you how the whole thing works. All right, so they tell you how to do the calculation, but they don't actually prove to you that the way that they calculate is the correct way. So we will be talking about triangle, parallelograms, and trapeziums. All right, now let's start with the triangle. Now, often um, people tell you that to calculate the area, you take the height, you time with the base, and then you divide by 2. Now, to show how to calculate the area of a triangle, um, what I'm going to show you is the height and the base. Okay, so here, now that is the height of the triangle, and the base is the length at the bottom. Now, next thing I'm going to do is I'm going to draw a box around it. All right, so now you can see there is a box here around it, and you can see some of the areas appear to be equal. Now, so what you see there, I'll call this area A, then you have B, and you have C, and you have D. Now, you see that A is equal to B, and you see that C is equal to D. Now, so what it means is that B plus with D is going to be the same as A plus with C. So the area of the triangle itself is exactly half of the area of the rectangle. You see that? So what it means is that if you calculate the area of the rectangle and then you divide by 2, you will get the area of the triangle. So to calculate the area of the rectangle, you have the height of it times with the base. Now that gives you the area of the whole box. Now half of it is going to be the area of the triangle. So that is the reason why they have the formula. The area of a triangle is the height times with the base divided by 2. Okay, now next we talk about the area of a parallelogram. Now I'm going to draw the height of it. Okay, so a straight line down. So that is the height, and you have the length of the other bottom, that and the base. Now I'm going to show you now on the other side. I will draw the height as well. Now you see that? So the triangle A and the triangle B, they are the same. So what I'm going to do is I'm going to swap the thing over to this side. Now you see that? So I'm going to swap B over to the other side. And the area of the rectangle shape is going to be exactly the same. Okay, so I'm going to draw that. Now, so from here, see, there we are. So the area in blue, the rectangle shape is the same as the area of the parallelogram. Now, for that reason, now I can just do the height times with the base, and that will give me the area. So the area of a parallelogram is simply the height times with the base. Now next, I'm going to talk about how to calculate the area of a trapezium. Now, the trick is actually quite simple. We are going to make 2 of this, and we arrange it. Okay, so Now we have two trapezium of exactly the same area. So I'll just take the original, I duplicate that, and I flip, and fit it in. All right, so now, if you got it, I'm going to call the length at the top. I'll just call it T, okay? So I'll call it T here. And at the bottom, I'll just call it B. So on the other one in blue, we flip it. So the top is actually down here, and the bottom is actually up there. So we have two of them. Now, can you see clearly that we have a parallelogram, and the base of it is B plus with T. And now I'm going to draw the height, and we have the height there. So now if you take the top, you plus with the bottom, and then you take the thing and you time with the height. All right, now you will get the area of the big parallelogram, which is twice the area of the trapezium. So all we need to do is we divide that by 2. So now the area now equal to top plus with bottom times with the height, and divide by 2. Now, so that is how you calculate the area of a trapezium. Now, this is the simplest way to prove it and to show the idea. Now, there is a more complicated way that the year 8 student or year 9 student may want to know, and that is to use algebra. Now, I'm going to show you that as well. The first thing I'm going to do is I'm going to draw. Okay, so I actually draw a small rectangle inside, and it also shows you the height. Now, the idea is I want to break the trapezium into 3 different parts. Then I calculate the area of each. Then I will add them. Okay, so I'm going to name a few things. So here you have the top, and down here you have the base at the bottom, and you have the height. Now I'm going to subdivide the base into 3 parts. So let's call that X, let's call that Y, let's call that Z. Okay, so we see clearly. Now the sum of X, Y, and Z will give you the base. The base is the entire length of the base. Okay, let's see how the calculation is done. Now the area of this one is simply h times with x divided by 2. Now the area of the rectangle shape at the middle is just h times with the top, and the area of the triangle on the right will be just h times with z and divided by 2. Okay, now the sum of all of them is going to give you the area of the entire trapezium. Now, I want the common denominator to be 2, so I'm going to convert ht to 2 ht over 2. Now, the area of the whole trapezium is going to be hx over 2 plus with 2 ht over 2 plus with hz over 2. Okay, now that is going to be equal to hx plus with 2 ht plus with hz over 2. Now, you can start paying the attention to the fact that x, y, and z, if you plus them together, you get the base. Now, we're going to factorize it. So that's going to equal to, we'll get the h out, and then you have the x. Now, then you have the 2t left over at the middle. So I'm going to just write plus with t. Now that makes 2t. And then we have z plus with z. Now the whole thing over 2. Okay, next. Now, you notice that x plus with y plus with z will equal to the base. Now, look at it. You see that the y and the t is actually the same because they are opposite side of a rectangle. See? So we can change it. So now we will change it to h x plus with t plus with y plus with z over 2. Now we can combine the x, the y, and the z together to give the base. So that effectively equal to h, the top, plus with the bottom, and divide by 2. So that's it, guys. That shows that the area of a trapezium is equal to h times with the height times with the top plus with the bottom and divide by 2. Now, this proof is a lot harder than the one I showed you before. The one I showed you before was suitable to show a year 3, year 4, year 5 student. That's fine. But the proof by algebra here is suitable for the year 8 and year 9 student.